Most people think two-sum has only one solution. In interviews, that's where candidates usually fail. Today I will show you a different approach to solve two-sum using a core DSA pattern called two-pointer. Two-pointer is not just used for this problem, but in many other problems that we will be solving in future. Hello everyone, this is day 3 of my interview preparation. Let's begin.
In day 1, we covered array basics and brute force two-sum. In day 2, we optimized it using a hash map. Today, we will learn pattern-based thinking, which interviewers care about a lot. Two-pointer works only when the array is sorted. If the array is not sorted, we sort it first. This condition is non-negotiable. Here, the array given to us is already sorted. Next, we place two pointers, one pointer at the beginning called left and one pointer at the end called right. Then we calculate the sum of the elements, and based on whether the sum is smaller or greater than the target, we move exactly one pointer. So the logic is, we first add the elements present at left and right pointer and check if the sum is equals to the target. So depending on whether the sum is smaller or greater than the target, we either move the pointer forward or backward. Now why this works? Because the array is sorted, moving left increases the sum and moving right decreases the sum. That's the key behind two-pointer. Now let's see the complexity analysis for this one. Since it is a linear traversal, it will be O of n log n because it takes exactly n log n times to sort a given array. And the space is O of 1 since we are not using any extra data structure here. So in interviews, remember, if indices are required, use hashing, and if the array is sorted, two-pointer is preferred. So in interviews, remember, if indices are required, use hashing. If the array is sorted, two-pointer is preferred. Because in case of a sorted array, we don't need to sort the array, which will reduce the time complexity to O of n. Now let's see the code for this. First, we sort the array because two-pointer only works on sorted data. Then we place one pointer at the beginning of the array and one pointer at the end of the array. Now we will place a loop. As long as the two pointers have not crossed each other, we will add the numbers at left and right pointer and check if the sum is equals to the target and return the value if it is equal. So that means we have found our target and we can return the value. If the sum is greater than the target, we will move the right pointers towards the left. At every step, we compute the sum of the two values at the pointers. And because the array is sorted, if the sum is smaller, we move the left pointer to increase it. And if the sum is larger, we move the right pointer to decrease it. So here we were given a sorted array 1, 3, 4, 6, 8 and the target is 10. The output is 4, 6, which is the expected result.
So this was day 3 two-pointer pattern on milli builds. From tomorrow, we will use this pattern in bigger problems. If you are also preparing for product companies, follow along and subscribe the channel. Thanks for watching.